And so let's go through our procedure for this. First one is to identify the number of nodes. And so this large one at the bottom here got the two sources connected to it, so it's probably the best choice for a reference node. This is a node here, and we'll have to say, I suppose, that the voltage there is unknown, but the voltage drop across this current source is difficult to find. We don't really need to know it, and so, you know, we're not going to call this a node. We can call this one here a supernode because the voltage is 25 volts lower than that our reference, and so that means that one node here. Okay, so I think the next thing for us to do then is to select a node as a reference node. And so that's this one here. And so I'll put my ground symbol on there, and that means that that's 0 volts. Right, so that's our reference node. Now, this node right here, the voltage right here, you know, in relation to our 0 volts down here, we got going up here from a positive to a negative. So that's a drop in potential. And so that's negative 25 volts up there. So that voltage is known. So we call that a supernode. And so we have to write an equation for this node right here. And so we call that voltage right there VA. Now, we got some currents, and so we said that this is easier when all the currents leave. Now the 5 amp current here, you know, it might want to call that one enter. Now you can call them leaving and then make them -5, but it's just easy for us to say that that current enters there, and that's 5 amps. Now IX, I'll normally call that one leaving there, and we call that one I1. So you can call him IX and let him enter 2 if you want. I don't think that matters to the solution at all. And so down here now, we call this one I2. So the sum of the currents that enters equals the sum of the currents that leave. And so we write KCL now at node A. And we have sum of the currents that enters is 5 amps equals sum of the currents that leave I1 plus I2. And we want to write I1 and I2 now in terms of Ohm's law, which means the voltage drop across the 20 divided by 20 ohms, it's VA subtract -25, right? So remember, I1 flows from a place of higher potential to a place of lower potential. So the voltage drop across it is VA minus -25. So VA on one side, subtract the voltage on the other side is -25. And on the bottom goes 20 ohms. Now plus I2. I2 flows from a place of higher potential to a place of lower potential. So we got VA subtract 0 over 30. So we got 5 equals VA plus 25 over 20 plus VA over 30. Now, again, there's a few ways to do this, and if we look for the lowest common denominator here, or the least common multiple of 20 and 30, it's going to be 60. So let's multiply the whole thing by 60. Okay, so 5 times 60 is 300. Is equal to 60 divided by 20 is 3. And you'll notice that I left out my subscript on this, and what I did there was put my plus sign instead of my subscript. And so let me fix that to VA plus 25. Now, back to 60 over 20 is 3, so I got 3 VA. 60 over 20 is 3 times plus 25 is plus 75. Now this term, 60 over 30 is 2, so I got plus 2 VA. Okay. So now I bring my 75, cross the equal sign, make it negative, so I got 300, subtract 75 equals 225, and that's equal to 5 VA. So I got 225 over 5, and that's not the right answer. Oh yeah, okay. Probably is. We got 225 divided by 5, and that gives us 45 volts. Got my cursor gone. Okay. 45 volts equals VA. And so now let's think about the answer to the question, because we were asked to find IX. And so IX is equal to, right here, right, IX, opposite direction from I1, negative I1. And remember that I1 was this expression right here. And so let's calculate I1, and before we put the negative sign in, just to try to cut the confusion here a little bit. So now I1 then is equal to VA plus 25 over 20. And so that gives us 45 plus 25 over 20, which is 70 volts over 20 ohms, and that is 3.5 amps. And that does agree with our solution from mesh analysis yesterday, right? Now, so then X, remember, is in the opposite direction, which means that X then is negative 3.5 amps, and that is the answer that we're looking for. And so, for a lot of these questions, remember that your final answer, the polarity is part of it. And so, you got to be paying particular attention to polarity all the time in these solutions, of course, because they're, well, they're algebra solutions, right?